What do you notice about these two ions that the acid and the base give off? If you look at them together, do you notice?
The H gives off a positive charge, and the OH gives off a negative charge.
Okay, the H gives off something positive, and the OH is negative. They're opposite. Good. So if they're opposite, what do you think happens when they come together? We can ask ourselves and then carry out through an experiment. Okay? Talk with your group. What's a question we could test?
What you said?
Can we determine the concentration of acid?
Yeah, like is there like an acid of some sort?
Yeah. Or both of them.
And what made you think of that question?
Concentration is our unknown, so we're trying to figure it out.
How acidic the concentration is.
Okay, how acidic the concentration might be?
Can you put how can we neutralize the acid by putting more base?
Okay, how can we neutralize an acid? All right.
You don't know numbers.
Yeah, of each acid and base, then they'll neutralize.
Then they don't neutralize because they'll cancel each other out.
We have. We made one.
Okay, what is it?
Okay, why you guys don't know? No, what was it?
If the acid and base have equal amounts, then the solution is neutral.
So your hypothesis is on the right track, but there's a way you can make it more closely answer your question. So try to fix it a little bit.
If we have equal amounts of acid and base, then the solution will be neutralized because the base and acid H ions cancel out.
We say that if acids and bases have same concentration, then they will neutralize each other because of their opposite charges.
You have your testable question, you have your hypothesis, and they're both good. Now I'm going to tell you what materials you're going to be using today, and then after knowing that, you're going to refine your hypothesis based on what you know you're allowed to use. Right now, I have an acid of unknown concentration and a base of known concentration. What is the concentration of the base?
1.0 molar.
1.0 molar. Good, so write that down. Or I think you have it already. Okay, it's in your material. All right, so you have a known concentration of a base and an unknown concentration of acid. I want you to incorporate those two ideas, or those two facts, into your hypothesis and refine your hypothesis. Not change it, refine.
We add the same amount of acid, that is 1 mole, to the same amount of base, that is also 1 mole. I think that the indicator will turn pink.
I think it makes sense because if there's a mole of acid and then a mole of the base, then they'll neutralize and then the indicator will turn pink. Because they'll have equal amounts.
So Jasmina, why did you change your hypothesis? I mean, I know, but can you explain it for the camera?
So I changed the hypothesis to refine it, to make it better. So I can prove, in the end of the experiment, I can prove it.
And how did you refine it? What new information let you refine it?
I included the indicator, and I say the concentration of base is known and the concentration of acid is unknown.
And then the base. But when does the indicator show?
When do you think it goes in?
I think it should show it.
Why?
Because when we have the base, we put the indicator after the base, we won't know exactly when it changes.
So then we would put the acid, and then the indicator, and then the base drops.
Sounds good.
The first step is add 3 millimeters of acid in the flask, and then add 1 drop of the indicator. which is phenolphthalein, and then add 1 drop of the base, then stir, and then repeat the third step until the solution stays pink, showing that the solution is mixed.
Okay, I like it so far. Things to keep in mind is,
What did I do? I don't know. My eye itch, that's why.
what data will you collect and how will you collect it?
Oh, we have to collect how many drops we're. How many drops of after we pour the drops. We have to like keep in track of drops until it turns pink. Oh, keep track of drops until it turns.
Until the solution. Wait, do we put that like in a table or something? We could put that for step 5.
No, I think we should put that for. This is the how we collect for making the chart. How you would I would do it. You will see. We'll put drops and then if 1 and then if it's neutral, non-neutral. No, put.
Okay, so we're putting
Non-neutral.
Yeah.
It's okay. We're good.
No, stop! It's 28? Okay, 28.
No.
It could be an error, I guess. It doesn't matter. Which one are we putting? 39 or 48?
Didn't we get 41, guys? Because Crystal mistakenly put.
So what data analysis method did you choose first?
We chose to find the average. Because there are 3 different ones, and we cannot do like for each one of them. It's better if we take the average of all of them. That's what I think.
What do you think?
That is a good idea.
What do you think, really? What do you think?
I actually agree with her.
Nisha, what do you think?
Yeah, I agree with her. We take the average of like all 3 of them.
Isn't it like,
Why though? Why would you do that?
isn't it like, I know this is not like isotopes, yeah, they're ions. Well, no, they're ions. But anyway, you know how like you take the isotopes and stuff, and it's like an average, and you have to calculate it to get that one. Yeah, because you cannot put all the isotopes in the periodic table. Yeah. By calculating the average, you get the amount of one, the whole thing.
Okay. So what data analysis method did you choose first?
We chose to find the average. Because there are 3 different ones, and we cannot do like for each one of them. It's better if we take the average of all of them. That's what I think.
Where you wanted to find the concentration of the what? The acid, right. Now, I made the acid myself, so I'm going to tell you the molarity of what I made, and I made it using this volumetric flask, so it's pretty accurate, and the molarity, for the camera to see, is 1.0 molar. Write that down, 1.0 molar.
H of the acid?
Of the acid. The acid is 1.0 molar. That is the concentration that I made. So, based on this new piece of information, what would be an appropriate data analysis method to use? Raise your hand. And why? And why? I heard you say it earlier. Percent error. What do you guys think? Percent error. Why would we use percent error?
To calculate the percent of how much we're off, like the percent of our error.
Okay. What do you think?
Not everything can be that accurate. You cannot be perfect when you do something.
Okay. Why do you guys think percent error is an appropriate method of analysis?
Because when you do percent error, you can kind of guess like what you did wrong compared to like the answer that
Error.
maybe the speaker wasn't as accurate.
Okay.
Because when you actually showed us the actual like the molarity, I think? Yeah, the molarity. The flask we used, I forgot the name of it, was like really accurate, and ours wasn't that accurate.
Okay. So maybe your equipment wasn't that accurate. Do you think your results supported or refuted the hypothesis?
Supported it.
Look back at your hypothesis.
And my supported it.
Why?
Because we had 1 mole of acid and 1 mole of base for it to neutralize.
What do you guys think? Did your experiment support or refute your hypothesis?
It supported,
Why?
because at 40 drops of the base, it neutralized with the acid.
Okay. How does
You were able to find the acid too.
Okay. How does 40 drops mean that it was neutralized though?
The temperature